I love video games. I've played video games my entire life, and one thing that always amazes me is the high quality graphics and attention to detail that all of these games have. I always wonder, how do they do this? And then I realize, it's because of graphics engines. I could probably code one, right? So you might be wondering, how exactly do we simulate such complicated and weird 3D environments using nothing but just code? Well, we need to use vectors. That's right, exactly the same vectors that we studied in math class. Well, I didn't exactly study them, I don't remember anything, but after some quick revision, I realized that vectors were effectively a way to represent any arrow in a space, a three-dimensional space. So I implemented a struct which could define a vector and then added all sorts of funny operations to it, like addition, subtraction, multiplication with scalars, multiplications with vectors, both dot and cross products, and division. And then I added a function called normalize. Yeah, this is exactly what I failed 2 years of math for. On top of this, I built another structure for arrays. Arrays operate similar to lines described by vectors, and effectively, we can determine light and color depending on whether these rays hit anything, such as spheres, planes, or axis-aligned bounding boxes. AABBs are kind of like boxes that align with all three axes on the 3D plane. Ray color helps us determine the color vector by using the surface normals to compute the Lambertian diffuse shading. Then I made a sky with a clever trick. Finally, I built GetRay, which builds the camera using a local coordinate system, and RenderFrame, which kind of renders frames. I stuffed it all into FFmpeg and stitched it together, and it worked out fine. Okay, this looks okay so far. Bro, you've got to be kidding me, what the hell? Yo, Raghav here. I realized I kinda messed up. I don't really have anywhere I can go with this project because I have limited shapes, limited features, and I got really lazy during the rendering programming, which kind of messed things up a bit. So I might genuinely have to restart. In this edition, I added the unary minus, which allows us to negate entire vectors instead of having to do it for each tiny component. I also created a component multiply, where each component of the vector can be multiplied uniquely, which is really useful when combining surface color with light color. Moreover, I added length squared and a new normalization technique, both of which were implemented for safety to avoid square roots and division by 0 respectively. Next up, I implemented the features clamp and reflect. This allows us to take the values inside of a range and kind of limit it to that range. Then, reflect basically uses the formula for vectors to reflect the vector v off a surface with normal n. Why? Because in Umbra 2, we have a new feature which is bouncing rays. Here's a new thing I implemented: materials. In the previous version, we kind of just hard-coded color within object branches. Here, we have introduced a material abstraction. In short, a material is a struct that tells the ray how to behave when they meet. It's kind of what keeps metal shiny and stone hard. I also built a struct called hitRecord, which allows ray hits to return a packet of shading data rather than just a point along the ray to hit that point. You might also notice that the light itself is a struct. This is because using a fixed light direction is boring and cringe, and a point light is far better. This introduces the ideas of positional lighting and distance falloff. Hittable is also a new class that was introduced. Instead of having case after case after case per each shape, this basically states that every object must implement hit. The sphere logic has been updated to use root filtering and closest valid root. The checkerboard pattern is less hard-coded, and AABBs now actually determine which face was hit by a ray. Instead of using a fake cube normal, this checks which coordinate is near a box boundary. This improves how light reacts with the box. Feeling tired yet? So am I. Let's keep going. I made a dedicated scene object and simple instruction functions to check hits and add objects. Now, even the camera is real. Instead of just using a camera computation, we have an actual camera with persistent state, which makes it easier to animate and swap between them. I also built a pseudo-random generator for sampling-based anti-aliasing and traceray to kill rays when the bounce count hits 0 to prevent infinite hyperactive bouncing like a bunch of 5-year-olds at bounce. I built a more accurate shadow computation, stronger light attenuation, and diffuse shading per material. We're almost there, guys, keep going. I implemented a Phong-type specular model and improved the color computation. Take that, Umbra V1. Finally, I added recursive reflections, gamma correction, multi-sample anti-aliasing, and stored frame buffers in memory instead of directly writing pixels. Last but not least, I improved all of the camera code and created a very nice way for me to create scenes. Looks easy, right? I spent more than 30 hours studying this stuff, going over articles with heaps of AI slop code and wrangling with techniques I could only ever pretend to understand. By the end of this, I was thoroughly dead inside and wanted nothing more than to retire in a faraway Swiss village as a cow farmer. And with that, Umbra V2 is finally done. Sure, it takes like 3 working days for something to render, but hey, at least it works, right? So what did it cost? I guess 20 years of my lifespan and all of my remaining sanity being in camp, but I guess it's kind of worth it. Would I do this again? Maybe if I'm paid enough?
I can't see the end, but we'll see it through.